This is an update on our NASA EOSDIS project. We will show excerpts from previous videos and then present our new work.
EOSDIS is the information management component of the Earth observing system. It will collect data from a variety of platforms and store the datasets in designated archive centers. Data users will browse, request, and download datasets over computer networks.
The current prototype offered by NASA is a classic form fill-in interface. Relatively complex queries are possible, but it is difficult to avoid the zero-hit problem or even estimate how much is available.
To facilitate querying and browsing, we extended our dynamic query interfaces to take into account the new challenges of EOSDIS.
Our early dynamic queries prototypes have shown that novices or expert users could rapidly query databases, explore trends, and find exceptions. But those prototypes used only a few thousand records, all in local storage, while EOSDIS implies more attributes and more records which are distributed on the network. To keep real-time interaction under those conditions, we propose a two-step approach. In the query preview, users query the whole database by specifying rough ranges over only a few attributes. This is the focus of this video. In the query refinement, users narrow the result set using higher resolution queries over all attributes. The first operational query preview at NASA was developed for the Global Change Master Directory. GCMD is like the yellow pages for Earth science datasets.
This interface shows 3 attributes available for selection. Users can set the area of interest. Let's choose North America. And we see immediately in the area selection that there are 1,913 datasets available. We might choose our interest to be the atmospheric variables, and so there are 843 now. And if we limit ourselves to data from 1970 to 1979, we're down to 298. The result bar on the bottom indicates the number that are available at any time. So if I click on related areas of the world, like the North Atlantic, we can see that I've moved it up to 346 datasets. 346 datasets are still too many to look at, so we want to refine the query further. The textual form of our query is right here on the screen, and we get 3 additional attributes from which to make selections. We can see that there are no datasets from manned spacecraft, a few from ocean stations, and most of them are from satellites, so we'll select that. We look at the sensor types, and we see again no data for cameras or infrared sensors, but there are 17 for radiometers, and so we now go to the data center selections, and there are only a few data centers that have this data. We'll choose all of them, the international agencies, NASA, NOAA, and the universities, giving us a total of 17 data sets, a nicely refined query, and so we go and retrieve the full records about these data sets. The 17 data sets we retrieved are listed on the left-hand side for us to explore, and if we click on any one of them, we can see the information about that data set on the right-hand side.
Query previews are based on tables of abstracted metadata. For a query preview using 10 topics, 10 year ranges, and 10 geographic areas, the table has 1,000 counts. When each record has only one value for each attribute, as is the case in most relational databases, each record falls nicely into one cell of this cube. However, NASA data is more complex, and datasets can cover several areas, several topics, several time ranges. The table has to include counts of the intersections and can become prohibitively large. One solution, used for GCMD, is to include the dataset IDs in the preview tables to remove the duplicates. This only scales up to about 10,000 records. We now present 2 new solutions that can scale up to any number of records. Here we are looking at a binary preview of the 60,000 records of the Coastal Zone Color Scanner dataset. It looks like this dataset covers most of the globe, from 78 to 86. But when I select an individual month on the timeline, I can see that the data is far from covering the whole globe. I can also select an area, such as South Australia, and see on the timeline when data is available. The binary preview technique tells user if there is any records for a given query, but does not tell how many records are available. The second solution preserves the counts, but restricts the query to ranges only and to 1 or 2 attributes at a time. This is the same CZCS dataset. On the timeline, we see how many records are available for each month. The scale is logarithmic and also color-coded. This shows that there are less than 100 records here and more than 1,000 there. As I select a time range, the result bar updates accordingly. I still have about 5,000 records, so I ask to select a geographic region. My time range is sent to the server, and a new preview table is loaded in 5 to 10 seconds. The color grid shows the number of records in each cell for the time period I selected before. I can select an area and see the total number of records for this area. At the end, I could just submit the query for those 239 records. We are now working on a design tool to help designers choose the number of attributes and the number of values, resulting in adequate performance.